Hello everyone. In lecture A2 of PEC, we will discuss the unit impulse function. Before the unit impulse function, we discuss the unit pulse function firstly. The pulse function means a function whose value appears suddenly and then disappears suddenly. For example, this function's value is 0 before t equals 0. At t equals 0, it suddenly becomes 1 over delta. When t is between 0 and delta, it keeps 1 over delta. When t is greater than 0, it suddenly becomes 0 and keeps 0 forever. This is a typical pulse function. Why is it called the unit pulse function? Because the area of the whole pulse window is 1 over delta times delta equals 1. So it's a unit pulse function. According to the discussion in A1, we know this unit pulse function can be expressed with the form of epsilon t. Pt, in which p means pulse, equals 1 over delta times epsilon t minus epsilon t minus delta. Obviously, the integral of pt from negative infinity to positive infinity is 1. That is, its area is 1. Next, let's focus on this unit impulse function. If we want to keep the area of the pulse window as 1 constantly, that is its unit character, but the width of the pulse window becomes narrower, such as half of delta. Obviously, its height needs to become twice of the previous. Now its height is 2 over delta, and it's a slim and a tall window function. Further, if the width becomes 1/4 of delta, the function changes to this form, and its height becomes 4 over delta. As delta becomes smaller and smaller, in order to keep the area of the window constant, the shape of the function will become thinner and thinner. When delta tends to 0, the limit of the function becomes the unit impulse function. Next, let's make a derivation. Firstly, we need to recall the expression of the unit pulse function. Pt equals 1 over delta times epsilon t minus epsilon t minus delta. And the integral of pt from negative infinity to positive infinity is 1. In this condition, when delta tends to 0, that is 1 over delta tends to infinity. The integral of pt from negative infinity to positive infinity is still 1. When delta tends to 0, the limit of pt becomes the unit impulse function. Which is called delta t. Now we give the definition of delta t. It has two characters. Firstly, when t is less than 0 and greater than 0, delta t equals 0. When t equals 0, delta t is infinity. Besides, the integral of delta t from negative infinity to positive infinity is 1. The two characters are the complete definition of the unit impulse function. Let's draw the graph of the function. This is a time axis. When t doesn't equal 0, the value of the function is always 0. When t equals 0, the value is infinite. Because we can't express the infinite value, we can only draw an upward arrow and mark a value 1 beside it. The value 1 means the integral of the function is 1. Besides, there's another discussion on this integral. Because delta t doesn't equal 0 only when t equals 0, Thus, it can also be written as the integral of delta t from 0 minus to 0 plus is 1.